Well, let's take a look at this question which says, in the button cells widely used in watches and other devices, the following reaction takes place. And you have a reaction. Determine delta G naught and E naught for the reaction. It's a lovely question with all possible characteristics of NCERT. What are the characteristics? Being illogical, being unreasonable, and trying to appear fascinating without actually. Actually, sometimes it can get disgusting. It's a very beautiful question which has been ruined simply because they have not cared to give you a KSP value. And that value is not present, and within the NCERT text also, it is not very easily locatable. So ideally, they should have printed that value. I am adding this value also. Without this additional value, you would not be able to solve this question, mark my words. This data should be a part of question which should be given. Oh, if it is not given, then it is stupidity. It is not some glamour or some fascinating aspect of NCERT. But nonetheless, I am giving this to you. Add this, and now this becomes a very beautiful question. Now let's try to solve this, right? There we are. What do? First, we write down the cell reaction. Well, anode, yes, we know how do we write down anode. Let's try anode. Zinc undergoes oxidation to give you zinc ions plus 2 electrons. That is so lovely. What about cathode? Had 2 Ag plus ions, accepted 2 electrons to give me Ag. That would have been great, but I don't have free Ag plus ions. As a matter of fact, I would need to consider another solubility equilibrium. And equilibrium constant for this is nothing but KSP here. Oh wow. So what do? I have 3 reactions. If I add them up, I would get overall reaction. And what is that? Let me just add and show you. Well, as I add them up, electrons do cancel. What else cancels up? You have 2 times Ag, and Ag plus ions also can be cancelled out. That's fine. And you get zinc solid plus Ag2O solid plus H2O liquid, giving you zinc ions aqueous plus 2 times OH minus aqueous plus 2 times silver. This is exactly the same reaction. Oh wow, so we have broken down the cell reaction into 3 components. Yes, these 2 reactions occur at cathode and this actually occurs at anode. Let me call this reaction 1, this reaction 2, and this as reaction number 3. Why is it? It is simply because I have to find out delta G naught for the overall reaction and E naught cell for overall reaction. Now delta G naught for overall cell, as you can see, delta G is an extensive quantity. If I add up 3 reactions, the delta G naughts of 3 reactions also add up. If that is the case, I have delta G1 naught plus delta G2 naught plus delta G3 naught. Is that the case? Yes. And how much would that be? Well, delta G1 naught plus G2 naught is simply if you add up only this much. If you add this, actually this looks like a different cell altogether. See, the Velen is the third equation, the KSP equation, which is the new addition. Do I know delta G for this? For any equilibrium, I know. For a reaction, delta G is minus RT ln K. So could I say that delta G3 naught alone, mark my words, be very careful, only this much is minus RT ln KSP. Okay, so I know delta G3 naught. Yes. Do I know delta G1 naught and delta G2 naught? Well, actually I can discover them. How? If you just add this much, you get a different cell. Can I just scribble down the cell here in a different ink so that it becomes visible to you? I believe I can. It is going to be zinc plus 2 times Ag plus giving you Zn2 plus 2 times Ag. Now this is a very regular metal ion electrode, the cell made by metal ion electrodes. And for this cell, E0 cell is E0 cathode minus E0 anode. Now cathode is Ag plus 2 Ag, which is 0.8 volts. How do I get, how do I get this 0.8 volts? From that fabled electrochemical series chart present in NCERT. And what about E0 anode? E0 anode is minus 0.76 volts. The minus of minus 0.76 volts, which is 1.56 volts. So only for 1 plus 2, I know E0 cell. And I also know a relationship. Delta G0 is minus NF E0. So delta G1 plus delta G2 naught, this will be equal to minus NF E0, E0 of this cell. In this cell, Ag2O is not there. Please note, in the original question, silver is present as Ag2O, and in our 1 plus 2 cell, silver is a routine Ag plus aqueous. It is not Ag2O, which is different. So this is minus NFE0 minus RT ln KSP. Is that the case? Yes. Could I calculate that? Of course I can calculate that. All I need to do is substitute. How much is N? The number of electrons which cancel is 2. So this is minus 2 into 96500 into 1.56. E0 cell is 1.56. Please note volts. So many joules per mole. Please don't forget to convert this into kilojoules per mole. Minus 2.303. R is 8.314 joules per mole Kelvin. Temperature is 298 Kelvin. Log of KSP, log of this dirty thing, multiplied by log of 3.72. God save me, into 10 is to minus 16. Fancy. What does all this exercise give me? I get delta G0 cell. All you need to do is now to substitute and calculate. Fanciful. And what does it come out to be? Minus 213.04 kilojoules per mole. This is delta G0 cell. Oh my God, that's a dirty calculation. It is one dirty calculation, but yes, you do get the answer. And this delta G0, once you have got this, you can say this is also minus NF E0. N is 2, F is 96500. Can you calculate E0 cell easily? And this E0 cell comes out to be 1.1 volts. Substitute, calculate, and get the answer. This is the correct solution to this question.